In this video we will discuss about the naive Bayes. It's a supervised learning method and it's basically uses the classification technique. Okay, it is a probabilistic technique. In this video we will discuss the other things about the naive Bayes, and we will derive the mathematical equation for the naive Bayes, and we will see some problems in the naive Bayes algorithm and then how to solve those problems. That all we will discuss in this video only. Okay, in the naive Bayes we basically use the Bayes theorem is the basic thing that we are using. Okay, uh, we know the Bayes theorem actually. Probability of A given B equal to probability of A intersection B by the probability of B. This is the formula for the Bayes theorem. Okay, by using this formula, if we build a algorithm, it will not performing well and it's take more time. Okay, to avoid this problem, they introduce the naive Bayes algorithm. In the naive Bayes algorithm, we have a condition. That means the features we are considered as independent to each other. That means we have features x1, x2, x3 and y is the output. These features are independent. Okay, x2 is not dependent on x1, x3 is not dependent on x3, x3 is not dependent on x1. This is the thing that we are considered. Okay, we will see mathematically what it is. Probability of A given B, that means features A and B are independent only when probability of A given B equal to probability of A. That means the event of A happening after B equal to probability of A. That means A is independent of B. Okay. Similarly, B is independent of A. And example is a die. Throwing a die is every event is independent to each other and mutually exclusive. When we'll say the probability of A given B equal to 0, at that time we will call this these two are mutually exclusive events. Okay, and Bayes theorem. We already said that the basic thing that we are using is Bayes theorem. Bayes theorem, probability of A given B equal to probability of B by A, probability of A by probability of B. These are the terms: likelihood, prior evidence. It's not necessary, just okay. And this numerator we can represent like this. Okay, that also we seen previous, and for simplification we use this like this one, a numerator. Okay, simply we will represent like this. Now we will implement the naive Bayes using in mathematically. We will derive the mathematical equation for the naive Bayes. Okay, let's x is a vector. That means in the data we have x1, x2, x3, x4. These are the features. Okay, independent features, and class label is ck. Let's consider. Okay, these all the things represented with only x, and ck is the class label. Okay, now here this was represent, this was the thing, probability of ck given x. It was represent given xk. That means given a test case, that means values, given some values, what is the probability of that was belongs to that class. That means ck, probability of c1 given x. That means x has some values. What is the probability of these x values belongs to class 1? Probability of c2 given x. What is the probability of these values belongs to class 2? That was represent, that was probability. Okay, yeah. In the naive Bayes, by using the Bayes theorem, we can rewrite this one like this: the classes probability of ck given x is probability of ck, probability of x ck, probability of x, probability of x intersection ck by probability of x. Okay, what is it? Okay, now we will see. For the class 1, we know that one is represent probability of x intersection ck. We'll simply write probability x comma ck. Okay, similarly by this way we will write this one. We'll see this like this. Okay, now we will get the values according to the, we will get this value for the class 1. It was represent the values belongs to class 1. What is the probability? What is the probability values belongs to class 2? What is the probability of the values belongs to class 3? The which value will get more, the values are belongs to that class. That means if we get the this probability value is more, then the these values are belongs to class 2. That was it represent. Okay, now here we can observe that the values we are getting by this value, these functions. Okay, these probability values. Here we can observe in this all the denominators are same. Okay, that means this function is directly proportional to the numerator only. This is probability of ck given x is directly proportional to the probability of x comma ck. Okay, that we will get here. Now going to this one. Here same thing that was represented. Okay, now go to the down. Yeah, it was same written probability of increases, that was increases. Now we'll derive the equation. We said the probability of x comma ck is more than the probability of ck given x is more. Yeah, that thing you know. The probability of ck ck comma x was represented like this. Okay, ck comma x1 x2 x3. This x is the representative, that was I am told before that thing. Okay, now we will rewrite this one like this. Probability of x1 comma x2 comma xn ck. It was look like this one. Probability of a comma b. They will rewrite this probability of a given b by probability of b by using the Bayesian theorem. Okay, now a as x1 and b as these all the things. By the considering that way, probability x1 given x2 comma x3 ck into probability of x2, we will get like this. Okay, now we need to find this one because it was same thing look like this one is same, these two are look like same. Okay, now in this x2 we consider as a and remaining thing we consider as b. This is like a chain equation. Yeah, this is like a chain equation. Now will same thing, probability of x2 given x3 x3 x4 ck into probability of x3 x4 x ck, and this is also similar. Okay, this is also similar like this one, and then we will apply this on this also chain rule. By applying this whole thing, we will finally get probability of ck comma x. That means probability of ck x1 comma x2 3 by this. For this, for this, we'll get the equation whole thing. Okay, for this we'll get the whole thing. We'll get this one we will get. Okay, now let's see. Now it's come property of condition independent. Probability of a given b equal to probability of a. Similarly, probability of a given b comma c we can represent because a is independent of b, a and b are independent. We will rewrite probability of a given c. Similarly, we have xi, we have similarly probability x1 by x2 xn ck. We will rewrite this one into probability of x1 by ck because x1 is independent of x2 x3 xn. Okay, that's why we will directly get probability of x1 given ck. Okay, we will get directly this one. when we get like that one, now we will get the equation like this: probability of x1 ck, probability of x2 ck, probability of xn ck, probability of ck. Now we will simply rewrite probability of ck by I into 1 to n probability of xi ck. We will go with an example, then it's very easy. Now we'll consider, yeah, the final equation look like this. The y is the class level, which class it belongs to. Argmax of k equal to 1 to k. That means it is the class. Which class we are getting these values maximum. The k represents class 1, 2, 3, like that. For which class we are getting this maximum value, that k value it will assign to the y. Okay, that was the equation represent. The time complexity here if we get is order of n. Okay, we will go with an example, then it is very easy. Now in the way here we consider the text classification, a review is positive or not. Okay, if it's a negative review we'll consider 0, for positive review we'll consider 1. And the data we have text. Each text has a class label. Okay, we don't send the text data, we need to convert text data into the numerical data by using the bag of word is one of the technique. We are using the convert the text data into numerical data. By the converting the data into numerical data, we will get the d-dimensional. Okay, we'll get the d-dimensional data like this. Okay, w1, w2, w3, and y. Each feature represent a word here in this bag of words. Okay, when you know the bag of word technique, you will understand very easily that one. Okay, now probability of a text is given. What is the probability of the text belongs to class 1? In the text we have words w1, w2, w. For each word, the word belongs to class 1, word 2 belongs to class 2, word 3 is present in class. Not we will get the probability according to that, and finally we will get some proportional probability. Here we are only getting the proportional probability for the probability the given text belongs to class 1 or not. We will get some probability here, proportional probability. For class 0 also we will get the some probability here. Which probability is more, we will classify the text belongs to class 1 or class 0. That means review is positive or negative. Here we will see that probability of w1 given x1, what is it, and probability of y equal to 1, what is this, we will see. We will know these all the things also. Probability of y equal to 1 represent number of trend points y equal to 1, total number of trend points. Thus data we have data points. Let's say n is the number of total points. In this some points has y equal to 1. That means how many number of points y equal to, that was represent numerator, and the total number of points n is here. Similarly for probability y equal to 0, number of points y equal to 0 and total number of points. Now probability of w1 1, what is it, that means of the number of points with contain word w1. Here we will have text data. Okay, the text data we have words. Okay, the we will only count the points, the points only the word w1 and the class label also y1, y equal to 1. We will count these rows and the number of points with y equal to 1. That means number of data points y equal to 1. By these two things we will get the probability of w1 given y1. Similarly for every word we will get the same thing like this. Okay, Now up to now is okay. What if what if what if probability of W1 given y equal to 1? We have to get this one. It represent the points W1 present and y equal to 1 and the y equal to 1 number of points. Okay. What if the W1 is not present in y? At that time we will get the probability as 0 and then we will get y equal to some value something n1 we will get, that means 0 by n1. By getting this one 0 we will get probability for probability equal to 0 because probability given x represent the combination of probability of ya given y, that means pi we are using. Okay, by using we are using multiplication tab. If 1 is 0 all that I'm going to the 0. Okay, to avoid this problem we are using the Laplacian smoothing is one thing we are using. By using the Laplacian smoothing we avoid this problem that we will see now. Yeah, sorry. Yeah, in the Laplace thing we will write we got 0 there I am told that, and plus alpha n1, that means number of points class belongs to class 1, and alpha into k is the hyperparameter. Alpha is the hyperparameter, k is the number of classes. If it is binary classification value is 2. If 3 class classification k value equal to 3. Okay, like that only. Now what is the alpha value? What if alpha equal to 1? When alpha is considered as a 1, that means very low value. Alpha is low value. When consider alpha equal to 1, we will get very low probabilities. Okay, that means the model is going to overfit. That is a problem. When consider alpha value is very high. When consider alpha value very high, then the probabilities, that means we'll get the all the probability of W1 given by 1. For all classes we are getting same probability, that means it is underfitting. Okay, we will tune the hyperparameter value by using the cross validation check. Okay, that thing you know already, but we are okay. ck sorry here we are using the multiplication term we are getting. Actually probability values are less than 1 and greater than 0. Okay, less than 1 we are getting. If we have those points are multiplied 0.02 like this, if you multiply this point we are getting very decimal value is decimal place is increasing, that means stability, this value is not numerically stability, they are losing stability. To avoid this problem we are using log. By applying log we are not getting any. Here we will apply the log. By applying log we can easily convert the multiplication term to addition. That is the one benefit by applying the log. By applying the log on both sides, we will get final equation log of probability of y equal to 1, sigma equal to 1, probability of given by y equal to 1. Feature importance in naive Bayes, it is very easy. For each feature we will get some probability. Based on which feature having highest probability, that is the most important feature, and we can get like this. The next probability value is the next most important feature, like that only. Next we will have sorry. Next we will coming to the C, missing values. Missing values also considered a class in the naive Bayes. That is a good thing. And here we have different techniques like multinomial Navier-Bayes, Gaussian Navier-Bayes, and Bernoulli Navier-Bayes. These are the different things in the Navier-Bayes. Okay, under this Navier-Bayes we can easily extend to the multi-class classification, because we are getting the probability of all classes. Okay, and then here here we don't get by the similarity matrix, because we are not using the distance method, we are using the probabilistic method. Because of that, the similarity matrix or distance matrix won't work here. Okay, and we can apply for the high dimensional very easily. Okay, because we are using the log probabilities, we can easily apply to the high dimensional data also. If we are not using the log probabilistic method, that time we will face some problems.